Okay, let's delve a little bit further into the land of line of best fit. And today we need to be looking at the equation of the line of best fit. There's two different examples I want to show you, but just a quick recap real quick. Remember the basics of equations. Basically, y equals mx plus b. That m is going to be your slope. M will always be your slope. Sometimes it's a fraction, sometimes it's a decimal, sometimes it's a whole number. And then the b, that would actually be your y-intercept. That tells you where to put the dots on your y-axis. And so that's how you would generally handle this. And now let's get into the first example. The height of several adults were recorded. And so what I'm going to do is I'm going to say, hey, all of this shaded in blue right here is basically the height and weight right there. This is bigger. And then I went ahead and made a graph, a scatter plot of that table. So if you had to go and make a scatter plot of this table in blue, it would look like what you've got here in pink. And then the last thing I wanted to show is that they said it was discovered that this was modeled by the equation y equals 49x minus 134. And I've got that one sitting right here. So that way it's a little bit easier to see that equation. So we're saying the line of best fit is going to be modeling this stuff in green, so we don't need all this stuff at the top. And then we'll get into what the question wants here in just a second. So let's get all of this off of here, and let's go to a page where we can look at it a little bit closer. Okay, so here we go. Basically, we gathered up some data here of people's heights in feet, 4.55 feet, 4.8 feet, that sort of thing. And we got their weight as well. And if you went and you plotted this table out and made a scatter plot, it would look like this. Now, this was straight off of my graphing calculator. Now, if I asked you to go draw a line of best fit, like what we taught you to do yesterday in the previous lesson, um, what you would do is you would be like, well, let me circle my points, and then this time I'm going to get a red dashed line here so it stands out. And then basically I'm trying to split this as best as I can, and our line of best fit would look something like that red line. Well, what they do is they figure out what is the equation for that line, and that line is going to cross the y-axis way down here. And it's actually going to be at minus 134, negative 134 on the y-axis. And the slope is a positive 49.9, almost 50. It would go up 50 and over 1, up 50 and over 1, up 50 and over 1. And so that's what's happening with this line of best fit. They actually give us this equation. That's given this time. And they call it the model. But really, this model right here is nothing more than the equation of the line of best fit. Okay? So this is the equation of the line of best fit. Okay? And yesterday, we used this line of best fit to predict what it would be. Like if basically it's the same thing, we'd say, hey, what would it be at 5.3? Well, if this is a 3 and this is a 4 and this is a 5, 5.3 would be right here, and we would run it straight up to this line of best fit, and we would run it all the way over here, and we'd find out what this number is. The problem is my graph is not numbered, is it? My scatter plot has no numbers on my y or x axis. And I did that on purpose. I wanted you to see what the scatter plot would look like and how you've already done this. But basically, it's as if we said, hey guys, can you do this without looking at a scatter plot? We might show you the scatter plot, but we're not going to give you numbers. And basically, we want you to be able to just use the model, the equation. So if I covered up that scatter plot so you can't see it, it'd be as if they gave us the table of data, they gave us the model, this linear equation, and we said, could you tell me what the weight would be for somebody that's 5.3 feet tall? It's pretty simple. The height is x and your weight is y. So see where it says feet tall? That's your height. That's your x. That's as if this was an x value. And your y value is sitting here missing. So we come down here and we take the equation y equals 49.9x minus 134. And where we see this x value, this 5.3, we plug it in right here for this x. And so y would equal 49.9 times 5.3. We slide that right in there, okay? And then we minus the 134. We plug that into our calculator. We multiply these two numbers together and then subtract 134. And we quickly find out our weight, which is the y. And I'm typing that in my calculator right now. And we would see that the weight would be about 130.47 pounds. That's what it would be. So how much would that person weigh? It'd be about 130.47 pounds. Now let's look at it this way. 5.05 is less than 130, but 5.6 is more than 130. So 5.3 would indeed fit very nicely in between these. And this line of best fit, it predicts. It's not saying exactly they'd be 131 pounds, but it'd be about 131 pounds or so. It does say round to the nearest tenth, so let's go ahead and take the 7 and round it up to the nearest tenth. And so we would say, hey, 130.5 pounds. This would be your answer. So that's how we do it. If they give you the model, plug in the x or the y value that they give you and work backwards to find the other variable. Let's go to another one. This one's a totally made up creation. I made this table up myself on my graphing calculator, but let's just say that I decided I wanted to learn to carve, and every night I carved a little more than the previous night, and I recorded my time carving. The first night, I cut myself, so I only carved 5 minutes. It was very frustrating, didn't know what I was doing. The second night, I thought I was doing a little better, and I did 12 minutes, and so there you go. You see this pattern. I plot my points. I make my line of best fit. You know, I drew this through, and as you can see, I did a pretty good job of um, plotting out the line of best fit. I'm just showing you that this would be 10 on uh, the y-axis. This would be 20, 30, and 40. And now they're saying which of the following equations models this data right here, or this scatter plot, because they're the same information. And now you've got 4 equations that you need to see represents this carving time data. Also, I should tell you that x is number of days, and y would equal number of minutes, okay? Or total time carving. So this y would be the number of minutes, x would be the number of days. Now, the first thing that you look at is you would see that this is a positive relationship. That means that your slope has to be positive. If it was a negative relationship, we would say the slope has to be negative. And your slope is sitting right here, right in front of this x every single time. And you'll notice something. Which one of these has a negative slope? Well, C has a negative slope, so we can instantly say this is gone. The rest of these, they have slopes that are pretty close to each other, and we have no clue. I mean, it's hard to see about that. So the next thing that you do is go, well, let's take a look at the y-intercept. If this is 10 and this right here is 0, I'd say it'd be less than 5, wouldn't you? Yeah, I'd say it'd be less than 5, but it's definitely going to be a positive number. Do you see right here that my y-intercept for D is minus 4.235? That means it's sitting way down here below 0. So it's not going to be D either. Now that gives us 2 equations to work with. How do we go and test it? Well, I say take your x value of 1 and plug it in here and see which gets you closest to 5. So let's do the first one. Y equals 4.964x plus 1.143. Our x value is 1. So right there is a 1. 1 times 4.96 is 4.96. And 4.964, sorry, it's 4.964 plus 1.143, we're just adding them up, would get us 6.107. Now that's close to 5. Keep in mind, the line of best fit, it's not exactly there. We're just saying what's closest. So now I'm going to go to put this one in green, and let's try this one. Y equals 6.272x plus 2.5. Let's go and let's plug in a 1 here and see if we get a 5. So our 1 goes in right in there for the x, and we multiply it, and then we add them up. 6.272 plus 2.5, and I see that y would get us 8.772. Of these two models that we have left, of these two equations, which one is getting us closest to 5? It's definitely A, and that's why we would choose it, not because it's getting us exactly 5, but because of our options. This equation is the best. It's got the positive slope, and it's got a y-intercept that kind of works for us, and it's also the closest that we have of getting to 5. And you could choose any of these other points, but you always want to go with smaller numbers if you can, because it makes your multiplying easier.